I'd like to share my research on an interesting intersection of machine learning and video game categorization. I aim to answer two research questions, each proposing a unique machine learning task. The first one is how to classify video games into genres based on textual descriptions. The second one is how to classify video games into genres based on art covers. Here is an example of textual description and art cover from Destiny 2. This research takes the advantage of the Steam Games dataset from Kaggle, featuring over 75,000 entries. It contains over 10 features, but I only utilized 3 target features: genre, description, and URL to download art cover. I clean this data by removing unwanted features, rows with non-values, or genres associated with non-video game softwares. For textual descriptions, I split the data into training and testing sets, tokenized and normalized the text. For art covers, I downloaded the images using URLs and divided them into training and validation sets. It is noteworthy that sports and racing categories have much smaller sample sizes compared to others, because they typically can't evolve beyond real-life sports or racing. The first model I employed is random forest classifier. The random forest model was optimized through a grid search of 81 combinations with 5-fold cross-validation. Looking at the ROC curves, the model had a notably higher accuracy in predicting racing and action games. The model showed mediocre performance in classifying 8 genres based on textual descriptions with an overall accuracy of 0.47. I also want to specifically point out racing and sports games. The model has high precision but low recall in predicting them, indicating that positive identifications of these 2 genres are mostly correct, while a lot more games that belong to these 2 genres are misclassified into other genres. Since the decision trees in the random forest model are too complex to be visualized for interpretation, I found out the 10 most frequent words in the 10 most significant PC components with its feature importance. Most of them are nouns associated with certain game categories. For example, vehicle, drive, racing, and car in component 12 is clearly associated with racing games. For error analysis, I want to talk about a misclassified case where Among Us, a casual game, was predicted as an adventure game. The primary reason may be the discrepancy between its gameplay and theme. Its casual gameplay involves simple tasks and open online discussions. However, in the description, spaceship, departure, crew, imposters, and killing may suggest an adventure theme. Therefore, a possible solution is to separately label games' gameplay and theme instead of genre in general. To interpret complex image data, I applied image augmentation techniques to the training set and employed a sequential convolutional neural network model with 32 batches and 20 epochs to train on it. However, due to limitation in my computational resources, I was unable to fine-tune it with different settings and parameters. Based on the loss curve, the model improves very slightly over 20 epochs and stops improving toward the end. The ROC curve, which resembles random guesses, shows that the model struggled to consistently classify genres based on art covers. A misclassified game I want to talk about is Grand Theft Auto 5, which is an adventure game but was predicted as an action game. From the art cover, there are vehicles and weapons, which are action elements. However, adventure elements like different characters and scenarios are also present in the image. Therefore, the issue may be that one game can be classified into 2 genres without a strong inclination. One possible solution is to label and predict games as multiple genres, which requires multi-output models. Both models have their pros and cons. Random forest prevents overfitting and offers feature importance, but has limited interpretability, especially in context understanding. In comparison, CNN offers sophisticated techniques such as spatial hierarchy learning and automatic feature extraction, but requires much more data and computational resources. In conclusion, the random forest model had a mediocre performance while the CNN model was far from satisfactory. Both models may benefit from a more diverse dataset, and pre-trained models and fine-tuning can be applied to CNN when adequate computational resources are available. Most importantly, based on error analysis, the dataset can be improved through labeling games gameplay and theme with multiple categories. Feature concatenation can also be employed to combine both models to improve performance.